Session 2, Topic 1, Foundational Concepts of Performance Testing and Performance Engineering. In this topic, we are going to discuss about the basic and core concepts of performance testing and performance engineering. So if you are someone who's new to performance testing, it's very important that you have a clear understanding of these basic concepts, because throughout your performance testing journey, you'll have to explain these concepts to different stakeholders and clients. Whenever you read out the performance testing report, there will be a lot of questions, so you need to have a clear understanding of these basic concepts. Only then you'll be able to explain it to the client in case if they have any queries. Okay, so now let's try to understand these basic concepts. First, we'll start with what is performance testing, what are the roles of the performance tester, what is performance engineering, and what are the roles of a performance engineer. Performance testing. Performance testing is a type of non-functional testing, a technique using which we can evaluate the performance of the application when the application is subjected to different load condition. Okay, so that's the simple theoretical definition of performance testing. Now, how do we evaluate if the performance is good or bad for an application? And that is using certain metrics called the KPIs, key performance indicator. Okay, using that metric, we can tell if the performance of an application is good or bad. So that is called performance testing. Now, coming to the role of the performance tester, it includes right from the requirement gathering, where he tries to understand the application, what are the various flows in the application, and then write a performance test case or the traversal flow document, documenting the traversal flow document. Once he's clear with the business flows, then he needs to convert those business flows into performance scripts, either a new load script or a LoadRunner script. Once the script is ready, he needs to build a scenario and execute the load test. Once the load test is executed, he needs to gather the reports, then analyze those reports, and based on the analysis, if there is any deviation, he needs to raise the performance defects. Then he needs to track that defect to closure. So that's the high level responsibility of a performance tester. And now coming to performance engineering. Performance engineering is like an extension of performance testing. It's a broader discipline which goes beyond performance testing. And performance engineering is something that can be incorporated throughout the SDLC lifecycle, starting from the design and unit testing, and during performance testing, and even during the support. So in all these different phases of SDLC lifecycle, performance engineer has some or the other role to play in that cycle. Okay, but in most of the projects, how it works is, usually it will be one team, performance testing and performance engineering team. It will be a one team, and performance engineers' role or responsibility involves whatever the defects that are raised by the performance tester, the performance engineer has to identify the root cause of that problem, and with the help of the dev or the support team or the functional SMEs or the architects, he needs to find a resolve for that problem. That's the basic expectation of a performance engineer in any project. And whether it's SAP application or other application, this performance testing and performance engineering concepts are the same at a high level. So now let's try to understand what is the difference. Maybe sometimes even some of your interview questions, right? They might ask, what is the difference between performance testing and performance engineering? So coming to the scope, the performance tester's responsibility is only limited to the testing phase. Whereas if you take the performance engineer scope, his scope includes starting from the design, development, testing, post-life support, right? Throughout the entire SDLC lifecycle, he has a role to play. And if you look at the approach, right, like performance testing is most like a reactive approach. You build the application, then you test and find the problem. Whereas performance engineering approach is kind of proactive. Even before the problem happens, he should be able to figure out the problem and solve that problem, right? And the focus areas of performance tester is just finding the performance defects. Whereas performance engineer's focus is finding the resolution of the defects as well as preventing the issue. Okay, so these are some of the key comparison between the performance testing and performance engineering. Hope that's clear. So now coming to key performance metrics. As I said before, key performance metrics are measure using which we'll be able to tell if a particular application is performing good or bad. So this key performance metric we can broadly categorize into two different types. One is client side metrics, the other one is the server side metrics. And client side metrics are nothing but the metrics that we capture from the client side. In most cases it will be a browser or a performance testing tool like NeoLoad or LoadRunner that emulates the browser. So the metrics that are captured either from the browser or the performance testing performance simulator tool are called client side metrics. There are many client side metrics, but 99% of the project they care about only the transaction response time and the throughput. Transaction response time is nothing but when a request is fired from the browser, right? It goes to the server and get the response back, render the response back, right? That round trip time is called the transaction response time. And throughput is nothing but number of transactions that happens in a unit of time. It could be a minute or it could be an hour, but most of the times for reporting purpose we measure the transaction per hour. So number of transactions that happens in an hour. So that's called throughput. So these are the two key client side metrics that we have to capture for performance testing. And now coming to the server side metrics. Any metrics that are captured from the server, whether it could be a web server or application server or database server or your middleware, right? Any metrics that are captured from the backend are called the server side metrics. There are so many different metrics, but 90% of the time we'll focus on only these two metrics. That's CPU utilization and the memory utilization of the server at a very high level. Because in a environment, in a complex distributed system, there are so many servers, so many middleware technology. So it will be very difficult to capture all the metrics for all those different servers. So we can limit our metrics just to CPU utilization and memory utilization for reporting purpose. Okay, and the reason I'm saying this is initially for tracking you might need to capture more metrics, but for reporting these metrics are enough, because whenever there's a performance issue it will show up in the transaction response time, and if the transaction response time goes high, your throughput will automatically reduce. And if a transaction response time is high due to more time taken by SQL or a function taking more time, right, it will also reflect on the CPU or the memory. So these four metrics are the core metrics. Two from the client side metrics, that is your response time and your throughput, and on the server side your CPU utilization and the memory utilization. These four metrics are more than enough to pinpoint a performance problem in any application. Okay, now coming to performance testing candidate. As I said before, the role of the performance tester is to capture the requirement gathering, right? So as part of that, while we are trying to understand the application with the help of the functional team or the developer, right, they will give all the possible business flows in that application. But for performance testing we don't have to consider all those scenarios. So there are certain criteria based on which we can define the candidates that we need to test. When I say candidates, the performance business flows. For example, criteria number one is your business critical transaction. If there is any transaction that is very critical for business, we need to include that in our performance testing. High volume transaction. Any transaction where the volume of traffic is very high, we need to consider those scenarios for performance testing. And criteria number three, data intensive transaction. Any transaction that deals with processing a lot of data, we need to consider that for performance testing. So based on these three criteria, you need to have a discussion with the functional team or the developer and identify them for performance testing. This is very important. In most cases no one is going to say either you have to PT the scenario or not. So you need to do some analysis and have a discussion with the stakeholders and ensure whether this is required for testing or not. Okay, then comes the non-functional requirement. Non-functional requirement are nothing but if an application is built, right, there will be certain expectation from that application. There are certain criterias that are expected from that application, right? For example, whether the application can handle 1,000 users, or if it can handle like 1 million transaction an hour, right? So there are some criteria, and the CPU utilization should be less than 80%, memory should be somewhere around 80%, right? So these are some technical criterias that are defined by the business and the technical team. So these criterias are called the non-functional requirement. Majorly, the utilization, CPU utilization threshold, memory utilization threshold, and the transaction response time, how much of traffic is expected from that particular business scenario, right? So these four are the key non-functional requirements that we need to know before we start the performance testing. If you do not know this, engage with right stakeholders and get this details from them. Now coming to workload modeling. So this is another key responsibility of performance tester. Once we get the non-functional requirement, we need to build a scenario. Maybe the scenario might have some 10 business flows, so we have 10 scripts, and each business flow has to be executed. Maybe if you might be 1,000, 2,000, they might come up with some whole bunch of numbers. So now we need to mimic the traffic with virtual users. Okay, I think I need to explain what is virtual user before I explain this in detail. So virtual users are nothing but users that are simulated from using the performance testing tool, either the NeoLoad or performance or LoadRunner, right? So if you take in the real world, right, like there will be 1,000 users trying to access the application, and for performance testing we cannot mimic that. We cannot have 1,000 users and ask them to run different business transaction at the same time, right? That's impossible. That's where the performance testing tools like NeoLoad and LoadRunner came up with this concept of virtual users. So each users will be more like a service which will execute that script for us. Once we go into the future session, right, you'll get to know what that means. And if you're already a performance tester, you'll be already aware of it. Okay, so coming back to the workload modeling, right? So using the virtual users, we need to simulate the traffic, right? For few scenarios might require 10 users, few might require 50 users, and if the traffic is low, we have to give some wait time, think time, pacing, right? All those things. I think that's a separate topic that we have to discuss, but for now, okay, just try to understand. Approach used to identify the number of virtual users, we used the pacing, all those scenario setting, right? We have a mathematical modeling to identify those numbers. So that's called the workload modeling. Okay. Then coming to the SLA, service level agreement. So this is again, it's part of the NFR requirement gathering. So while we are defining the requirement, we also have to establish SLA for each business transaction, right? If you're testing 10 scenarios, each scenario has some 10 business transaction, right? You need to get an understanding of like what is the time that particular business transaction should take SLA. So typically in most applications they give a blanket SLA of 2 seconds, 5 seconds, right? And some cases, if it is a very complex business transaction involving like more than 5 or 6 calls, right, might not be able to fit in your 2-second SLA. So first get that blanket SLA and try to test your application and see if it is able to meet that SLA. If it is not able to meet SLA, sometimes we have to explain them, this particular business transaction is a little complex. So do you still want to optimize this to respond within 2 seconds, or is there some leeway, right? Like instead of 2 seconds, can we have 5 seconds? SLA is nothing but getting the expected time that particular transaction should take is called the service level agreement or the SLA. Then we have the baseline. Baseline is nothing but when you run the test for the first time, right? So you get certain performance metrics, right? Response time and throughput, right? The pass rate and the failure, all those stuff, right? The first time you test an application, that's called your baseline. And benchmark is nothing but sometimes if you don't have a defined SLA, and if your business or the technical team do not have any clue on what SLA they are expecting, so you need to benchmark. Once the application is ready, you test that application with the whatever the non-functional requirement you have and get the results, and have a discussion with them. Is this aligning with your expectation? That exercise is called benchmarking your application. Okay, so now coming to the performance bottleneck. So this is another core concept. So performance bottleneck is nothing but the problems that you will encounter, especially the performance issues that you will encounter on different application stack. It could be a application server, a web server, database, infrastructure, or your middleware, right? Any performance issue. Bottleneck is nothing but a contention. So any issues that you see on any of this application stack, right? So that we call it as a bottleneck or a performance bottleneck. And now coming to the root cause analysis, I think this is area of performance engineer, or even if it's a single team, even the performance tester are expected to do the root cause analysis. So root cause analysis is nothing but once we identify the performance issue from our performance testing, we need to do a triage, right? Like using monitoring tools like AppDynamics or Dynatrace, right? You try to break down the transaction and see what are the different underlying calls in that business transaction is causing the problem. Identify if there is any SQL that is associated with the transaction is causing problem, or is it a function that is causing the problem, or is it the overall CPU or memory contention causing problem, right? There's an approach, there's a specialized approach. It could be a top-down approach or bottom-up approach, right? Using this approach, we should be able to figure out the root cause analysis. So root cause analysis is nothing but a systematic approach using which you identify the root cause of a problem. So these are some of the core concepts. Maybe some of the concepts I would have missed, but I think we'll be covering as we go into the remaining sessions. And when it comes to SAP Performance Testing and Performance Engineering is also pretty much the same, but in SAP it's we also simulate the web transaction, but we try to assess the performance on the enterprise side, right? For example, whether it's SAP, right? Within SAP, how we can assess the performance of different ABAP calls or the utilization. For SAP testing, it will be slightly different. So we'll be covering that in our coming segments. Okay. And again, coming to the key performance metrics, there are a lot of special metrics that we have to capture, like your batch processing time or the number of work process utilized. So we'll talk about each of these topics in the coming session. So these are very high level concepts, but make sure you have a thorough understanding of these concepts. And I think there's one more concept called the 90th percentile. I think in majority of your reporting discussion, right, you will have to encounter this question from your stakeholder. So as part of your performance test reporting, you provide the average response time, and there is something called the 90th percentile response time. So 90th percentile response time is nothing but 90th value. If you have 100 transactions, right, with having 100 different transaction response time, your average is the sum of all those 100 transactions divided by 100. So that will give you the average. But whereas the 90th percentile, what it means is if you sort that 100 transaction response time in a ascending order, right, the value that comes 90th entry, right, the value that you see on the 90th entry is your 90th percentile, which means 90% of your transactions are below that number. So majority of your projects, they go for the 90th percentile, so that if there are certain outliers, for example, a couple of transactions took almost some 50 or 60 or 200 seconds, right, you can ignore if you consider the 90th percentile. So that's something most clients ask us. Hope this was helpful. Happy learning. Stay focused. Thank you.